In this video, we're going to use the sleepwalking feature of the AVR UC3L to save power without sacrificing functionality. Our example application is very simple and generic. We have an analog signal that we want to monitor. The moment the signal overruns a certain threshold, we want to increment the counter. For the example, we control the input signal with a pot meter. So, the ADC takes one sample that the CPU evaluates. If it's below the threshold, we go directly back to static mode. If it's above, the CPU increments the counter before we go back to static mode to wait for the next sample. We do this every 5 milliseconds. Let's look at this in the oscilloscope. You can see where the UC3L wakes up from static and takes a sample that is evaluated by the CPU. The lowest level of the yellow curve is the static mode. The green straight line that we see is our input signal. The instant we have a threshold overrun, the counter is incremented by the CPU and the spike at the end extends a little. So, the CPU has to wake up for every sample to evaluate. Look at this analogy. The fence in the middle of the screen is our threshold value and the jumping sheep represents a signal. Notice how the word active flashed in red several times? In fact, only one of these 6 sheep made it across the fence, but the CPU had to wake up for every single one. This means unnecessary power consumption. We only care about the sheep that go over the fence. What we want is this. Now, the word active flashed only once. The rest of the time, the CPU was sleeping. We call this sleepwalking. And here it means that the ADC can evaluate its own samples and decide whether it's over or under a threshold or inside or outside of a window. When a value meets the predetermined criterion, it wakes up the CPU with an interrupt. Now let's take out the oscilloscope once again. This time it's different. Watch when you go above the threshold. Near the end of the pulse, the CPU is activated for the processing, and this peak is the same height as for the classic mode. Of course, our processing in this case is just incrementing a counter, but the point is proved. Sleepwalking saves power. Let's have a look at how much we save. The red curve is without sleepwalking and the green one is with sleepwalking. Agreed, these plots are rough, but a quick calculation indicates that the power consumption is cut by about 65%. We're using about 1/3 of the power that we used in the classic mode. We could be monitoring temperature, supply voltage, or an analog control dial. We could be monitoring a capacitive touch panel for touches. A 5 millisecond response time is much less than noticeable. You can also use sleepwalking with other tasks, like evaluating addresses on a multi-slave communication bus, where traditionally all slaves would wake up and have the CPU inspect all data to determine whether it should be acted upon.